Let's start with the best practices before going into an AutoBoom XRT calibration. For the machine, have it running at operating RPM. As for the field or lot condition, find somewhere that has enough flat area for the boom. This is very important because you will be calibrating inertial and radar sensors. Also, have a tape measure handy. The first screens in the XRT Calibration Wizard will display the hardware and software information for the two main system control modules. For reference, the ABM or AutoBoom Master module is smaller than the REM or Raven Expansion module. Next is the machine setup. Here you will go through the drop-down list to configure the wizard to match your machine. If you end up having questions on anything in the wizard, just select the information button to see descriptions for the items on each page. Next, you will verify the number of detected height sensors, and there must be an odd number of sensors in order to calibrate. Now on to the ABM Orientation. The ABM should be mounted on the machine chassis, and on this screen you will match the orientation to how it is physically mounted. Gravity will help determine if the ABM is upright or flat compared to the ground, but you will need to rotate the picture so it matches how it would look with respect to the forward direction of travel. Use the different arrows to rotate the ECU, and use the location button to change the perspective of the machine. This will be important for the terrain compensation on the next page. The ABM has inertial sensors that are used to measure the roll of the machine, which is why it must be mounted on the machine chassis. This allows XRT to move the boom in order to compensate when the machine rolls, especially in rougher terrain. Select the Calibrate Terrain Compensation button, and then move on to the next page when finished. Here you will see the width for your machine's center rack. It should be loaded by default, but it is a good idea to measure the width to verify. The next screen will vary depending on what your machine is using for a center rack angle sensor. There will be either a rotary position sensor or an inertial measurement unit, or IMU. If using the IMU, you will set the orientation to match how it is mounted on the boom, much like you did with the ABM earlier. You will also need to calibrate the IMU's inertial sensors. Now on to the height sensors. Enter the distance from the sensor to the boom pivot point, which will be where the boom wing meets the center rack. You will also need to enter the vertical offset for the sensor if it is above or below the bottom of the spray tip. Repeat this process for each sensor shown on the screen. Now you will lower your center rack below 8 feet, and then set your booms parallel to prepare for the next part of the calibration. From here, you will need to raise each boom until all of the sensors on that side are above 8 feet from the ground. This is actually doing two things. It's measuring the angle of the boom position sensor at the pivot point, and it's also determining the order of the height sensors along the boom. XRT will know where they are located because the outer sensor reading will be higher than the inner sensor reading, and the center sensor will have no change. This is why it is important to calibrate on flat ground, because calibrating on uneven terrain can interfere with this process. If you are using an analog rotation sensor for the center rack, it will need to be calibrated manually. To do this, it's best to go out to one side of the boom, and then rock it so the system can measure the amount of roll at the center rack. This could potentially take more than one attempt, so having someone else along can help a great deal. XRT will now need to calibrate the base control effort needed for the boom. Here you will need to raise the center rack all the way up, and then lower your boom wings until they are within 3 degrees of parallel. When you are finished moving the boom, turn the master switch on before going to the next page, because control must be enabled for this next part. From here, XRT will calibrate the control effort needed for each boom wing. They will raise and lower as the system learns the amount of effort needed to move the boom. Once that's complete, the wizard will display some summary information. You're now finished calibrating the system.